Hi everyone, in today's video we will do a ML project together. We will build a churn model using Python. We will apply several algorithms and compare the results, and we will also do some feature engineering. If you are new to this channel, I'm Karina, I'm finance person turned data analyst turned data scientist, and now I share my knowledge with other people online. A churn model is a predictive model used to identify customers who are likely to stop using company's products or services, known as churning. The term churn refers to the loss of customer. For example, you have a Netflix subscription and at some point you stop using Netflix anymore, you unsubscribe. For Netflix, you churned, you stop using their services. Same with Spotify, same with, for example, insurance companies. You've been using one insurance company and you left it and chose another company. So for the first company, you churned, you stopped being a customer. The churn model helps businesses to forecast customers at risk based on the historical data and behavioral patterns. In my work career, I've done several churn models, one for subscription business, one for gaming business, and one for pension funds, superannuation fund in Australia. Purpose of churn model: first one is customer retention, so companies identify those at-risk customers and they take proactive measures to engage and retain those customers. Second one is target marketing. Again, you identify people who are potentially at risk and you give them special discounts, you treat them differently, you market them with different campaigns, making sure they don't stop using your services. It's also used for resource allocation. Again, when you know customers that are potentially at risk, maybe you allocate a special people in your call center that communicate only with those at-risk customers, making sure they get the best service and they don't leave you. Components of the churn models are: first one is data collection. You gather in data about the customer, all the historical data, transaction, interactions with website or app, and their feedback. Second one is feature engineering. You identify and create new features that can influence churn. So it can be demographics, account balance, interactions with the product. Next step is model selection. There are several models that are most commonly used with churn models. It's logistic regression, decision trees, RandomForest, gradient boosting, and usually you apply several models and see which one performs better, and this will be your final model. The next step is training and evaluation. You train your model and then evaluate the performance of this model using accuracy, precision, F1 score, AUC, ROC curve. And the next step is deployment and monitoring. So you deploy the model, put it into production, and then you monitor its performance and you compare your predictions to real results. Example applications of churn models: telecommunication, when you switch in your mobile or internet provider. Subscription businesses, I think they have the biggest problem of churn. Banking and financial services is when you swap in your bank or you swap your insurance provider. And of course, retail and e-commerce. As you can see, churn model can be applied in different areas, different fields, so you can use the code you will learn today, apply it to a different data set and add it to your data science portfolio. Alright, let's begin. As always, we will start with importing the libraries. So the libraries we will be using is pandas, so we do import pandas SPD. We will use numpy, so we say import numpy as np. We will use matplotlib, pyplot for visualization, as well as seaborn for visualization. These two lines of code for that. From sklearn, this is a library that has all the scientific things required for machine learning. So from sklearn model selection, we will use train test split to split our data into training and testing dataset. From sklearn preprocessing, we will import standard scalar and label encoder. I will explain, of course, why we're using it. From ensemble, we will import RandomForest classifier. Then we will also be working with other models, not only with RandomForest, so I will import them as we go. From sklearn metrics, I import classification report, confusion metrics, and accuracy score, so we can evaluate the performance of our model. Let's run it. If you run it and you have an error, potentially you don't have the model imported, Python will tell you that module and the name of the module not found. In that case, you need to run !pip install name of the library to install that module on your computer. In my case, all these libraries already installed, so I don't need to run it, I just need to import it. For this project, I will be using data which I found at kaggle.com and link in the description. Let's read our file. So I'm creating a new data frame, df equals pd.read_csv, and then the path to my files. The dataset is called Churn modeling, and let's print ahead to see top 5 rows on my dataset. Okay, so you can see that's the dataset. So we have custom ID, row number, surname, credit score, geography, gender, age, 10 year. I think it is a banking data. Balance number of products. Yes, it is a banking data because it has card, active member or not. Estimated salary and exited. So exited is churn. If you want, you can rename the column exited to column churn. I will actually keep it as it is. A 1 means exited, yes, and a 0 means false. So no, he's still an active member. So you can see that some of the columns don't have any predictive power. Just from a logical perspective, columns like row number, custom ID, and surname, they don't impact prediction whether the customer will churn or not. So you can drop those columns or you can keep it. In my case, I will keep it. When you're building churn models, just try to think from a customer perspective. For example, again, you have Netflix subscription, you keep paying, but at the same time, you haven't logged into a Netflix account for the last 3 months. And with every month you're not logging in, the probability of you stop using the service increases. Or you have subscription to a fitness app, you're not logging in, you're not exercising, you're not using the app. Of course, at some point you will cancel the subscription. This is a type of behavior that is important to predict if you're gonna churn or not. Something about your name, surname, it's all not important. Let's look at our columns in more detail. So we'll use .info to do that. df.info brackets, let's run it. Okay, so we have 13 columns, we have just 10,000 entries. I on purpose always use small data sets for these videos, but of course you can find other bigger data sets and apply what you learn at these videos and use it for other data sets. Here we can see what data types we have. Next thing, let's check if we have any null values and if we have any duplicates. So to check if we have any null values, df.isNull brackets.sum brackets. Let's run it. We don't have any null values. And to check duplicates, we say df square brackets df.duplicated brackets. Let's run it. We don't have any duplicates in our data. So you can see at this point data cleaning is finished. Usually the next step, you explore the data, you create different visuals. You can, for example, create a bar chart to see how many customers churned, how many not. You can create a visual to see how many female and male churned and didn't churn. When you're creating the churn model project for your portfolio, I recommend you to add those visuals, but I actually will skip it because in this video I want to cover more ML models, feature engineering, and I will skip the visuals. So in my very first run, I will not create any new features. I will just keep the features we have. So we have number of products, has card, is active member. I will keep these columns. We will not bucket age, we will not create any new columns. The only thing we need to do, we will convert our categorical variables to numerical values using label encoding or one-hot encoding. When we were importing our libraries, we imported encoder. So we say label encoder equals a label encoder brackets, and then we converting our gender column because we have female, male. We need to convert it from categorical to numeric values. We say df square brackets name of the column gender equals label encoder dot fit underscore transform brackets, and then we can say name of the column df gender. And with one-hot encoding, to do one-hot encoding, we use .getDummies. So we say df equals pd.get underscore dummies brackets df comma columns equals geography. So we have the column which is France, Spain. We will use hot encoding for that column. So we say columns equals geography comma drop first equals true. There is another video where I talk in details about one-hot encoding, label encoding. You can check it out. In this video I talk about it faster and not going into details. Let's run it. Okay, no errors. The next step is feature selection. So we need to select the relevant features for our model. As I said, the row number, surname, custom ID, these columns that don't have any predictive power, just again from your logical understanding of the data. So you can either drop these columns the way I do. I create a new variable called features, and this is how I select the columns I will be working with. Before we do that, let's print df head again and see what columns we have now after we've done our one-hot encoding and label encoding. Okay, so you can see that now gender is 0 and 1, or female and male, and we have two new columns, geography Germany and geography Spain. So that's one-hot encoding. Now we can select the relevant features we will be working with in our model. So I say features equal square brackets, and in square brackets I indicate the columns I want to pick. So it will be credit score, gender, age, tenure, balance, number of products, has credit card, is active member, estimated salary, geography Germany, geography Spain. You never select exited or churn because this is a column we want to predict. So you don't select it in a feature. And now we say what is our X and what is our Y. So X is our features and Y is the column we want to predict. It is df square brackets exited, or if you renamed it, it will be a column called churn. So X features all the columns and Y is what we are trying to predict. Let's run it. No errors. The next step, we splitting our data into training and testing datasets. So we say x underscore train, comma, x underscore test, y train, y test equals train underscore test underscore split. This is what we imported at the beginning of this project. Brackets x, comma, y, comma, test underscore size equals 0.2, meaning 80% of the data will be our training data and 20% will be testing data, comma, random state equals 42. Random state is a parameter you use so you can replicate the result in the future. So usually it is 0, 1 or 42. You can pick any number, it can be 77 or whatever you want as long as you remember it. So next time when you have exactly the same data and you use exactly the same random state, you get exactly the same result. Let's run it. Done. The next part, we will scale our features. So we're scaling features for better performance. Feature scaling is a technique used to standardize the range of independent variables or features of our data. In the context of machine learning, feature scaling is a crucial step in data processing to ensure that all our features are on this similar scale. This helps to improve the performance and training stability of various machine learning algorithms. So again, it improves model performance, it avoids bias in distance-based algorithms like KNN, support vector machines, or clustering methods like k-means. It enhances model interpretability and prevents numerical instabilities. Common feature scaling techniques is mix-man scaling or normalization, it is standardization or z-score normalization, robust scaling, and max-ab scaling. What is important? When do you apply feature scaling? You need to apply it before you train in a model. So you apply scaling during the data processing step before you train in the model, and it must be consistent scaling. So you ensure that the same scaling is applied to both training and testing data. We will say scalar equals standard scalar brackets, and then we apply the scaling for both our training and testing datasets. So we say x underscore train equals scalar dot fit underscore transform brackets x train, and we do the same for our testing dataset. So x underscore test equals scalar dot transform brackets x test. Just think about scaling that we have a column age, and age is obviously from 1 to 100, maybe in this case from 18 to 100, while we have also column estimated salary, which already starts from something like 40,000 and 60,000 and goes to hundreds. Of course, if you keep those values as they are, if you don't scale them, it will look like estimated salary is much more important feature than your age, because different scales here from 0 to 100 and they're in hundred thousands. That's why we apply this normalization, standardization to our data. I always use a primitive example of a house where you have number of rooms, which can be from 0 to, I don't know, 5, and then you have square meters, which starts from 16 to hundreds of thousands. So you can see how different the scale of these values is. I will quickly display this transformed data just to see how it looks. So now you can see that's our X train, this is our X test. It was completely rescaled. And the first model we will use for our dataset will be a RandomForest. So we say model equals a RandomForest classifier brackets and underscore estimators equals 100, comma random state equals 42. So what random state parameter I mentioned before, let's talk about n estimators. So n estimators in decision trees is an integer that determines the number of decision trees that will be created in the RandomForest. When you increase an estimator, generally it improves the model's performance by reducing variance. More trees can provide a more robust and accurate model, but it also increases the computational cost and memory usage. On the opposite hand, decreasing n estimators reduces computational cost and memory usage, but may lead to less accurate model due to higher variance. Optimal number of trees is problem-specific and often found through experimentation or hyperparameter tuning techniques. As I mentioned before, I created a churn model for pension fund, and that model was running once a month. And in that case, you probably can create more decision trees. You can thrive for higher accuracy because you don't run the model that often. But if your model will be running daily or near real time, probably you can get less accurate models, so it's not that expensive. So of course, all the models we create as data scientists, we need to make sure that the cost of running those models is beneficial for the company. So if a company pays enormous amount of money for storage, for runs, and then it helps us to save a customer who pays $7 a month, is it worth it? So when you start increasing a number of trees, it might take longer to run, more expensive, but then it improves accuracy by 1%. Is it worth it? Then we say model.fit brackets x train, comma y train. It's always what you do to train the model. Let's run it. To make predictions, we say y underscore pred equals model.predict and brackets x underscore test. We make predictions based on our testing data, and now we will create confusion matrix, classification report. We'll calculate accuracy to evaluate the performance of our model. So we say conf underscore matrix equals confusion matrix brackets y underscore test, comma y pred. This way we will create confusion matrix. For classification report, we say class underscore report equals classification report brackets y test y pred, and accuracy equals accuracy score brackets y test, comma y pred. Let's run it, and we need to print those three things. Okay, so the first one is confusion matrix. I spoke about it before, but I will repeat it again. So confusion matrix is a table that is used to evaluate the performance of classification model. It shows the counts of factuals versus predicted classifications made by the models. So we start with a true negative, which is 1550 is true negative. This is the model correctly predicted the negative classes. So the model predicted the customer will not churn and the customer didn't churn. 57 is false positive. The model incorrectly predicted the positive classes. It's also called type 1 error. So the model predicted the customer would churn, but the customer didn't churn. Next line, we have 208. 208 is a false negative. So the model incorrectly predicted the negative classes. It's also called type 2 error. So the model predicted a customer would churn, but the customer didn't churn. And the last 185 is true positive. The model correctly predicted the positive class, the model predicted customer would churn, and the customer actually churned. Okay, the next one is classification report. 1 and 0, 1 is churned, 0 didn't churn, and for each of them we have precision recall F1 scored. Precision for positive class. The ratio of correctly predicted positive instances to the total instances predicted as positive. It is true positive divided by true positive plus false positive. Recall is the ratio of correctly predicted positive instances to all actual positive instances, and it is calculated as true positive divided by true positive plus false negative. and F1 score is harmonic mean of precision and recall, providing a balance between the two. So if you look at 0, which is non-churn, we have a precision of 88%. It indicates that 88% of the indices predicted as non-churn are actually non-churn. Recall is 96%, is that actual class 0 instances were correctly identified by the model, and F1 is harmonic mean of precision and recall. This support 1607, it actually shows the number of actual occurrences of class 0 in the dataset. Then we have the same for customers who churn. This is our accuracy score. And accuracy is a ratio of correctly predicted instances, both true positives and true negatives, to the total instances. So true positive plus true negative divided by the sum of true positive, true negative, false positive, false negative. And our result is almost 87%. Now we can visualize the feature importance. Okay, so we say importance is equal model.feature underscore importances underscore. This feature underscore importances underscore is an array of feature importances where each value represents the importance of a feature in making predictions with our model. Indices equals numpy.argsort importances and then square bracket py.argsort returns the indexes that would sort the importance array. Square brackets where ::(-1) is reverses the order of sorted indices, so the features are sorted in descending order of importance. Names equals square brackets features I for I in indices. This line will create a new list names where the feature names are ordered by their importance as specified by the indices array. So you will see what it does now. Then we visualizing it, so plt.figure brackets figure size 10:6. So when we create visuals, we always start with selecting the figure. With plt.title, we add the title to our visual, and then we will create a horizontal bar chart. That's why we say plt.barh, so horizontal bar chart. Brackets y-axis position of the bars are given by range x.shape1, so it's corresponding to each feature, and the length of bars are given by the importances indices. So you will see now, and plt.show is used to display the visual. And now we have our horizontal bar chart of feature importance, so we can see that age is the most important feature, and then estimated salary, credit score, and balance. There are several other ML models that can be applied to churn prediction problem, and they are logistic regression, support vector machines, k-nearest neighbor, GBM or gradient boosting machines, neural nets, decision trees, naive Bayes, and other boost. When I was creating model for pension fund, I did logistic regression and decision trees. Logistic regression was faster and more accurate, but the person who worked for that project before me created decision trees. No matter how much I tried to convince the customer that logistic regression will work better, I think they just really liked the name decision trees and RandomForest, so they said, please create RandomForest. We don't care how long it takes to run. It sounds more exciting than logistic regression. So sometimes it's not about accuracy, it's about what your customer wants. So let's apply logistic regression and compare results of RandomForest to logistic regression. From sklearn.linear model, we need to import logistic regression. To build and train logistic regression model, we say log_reg equals logistic regression, and then you say random state 42, and then log_reg.fit brackets xtrain, ytrain. To make predictions, we will say y_pred_log_reg equals log_reg predict x test. So we make predictions based on our x test data. And to evaluate the model, again, we create in confusion matrix, classification report, and we calculate accuracy. As you can see, model takes 3 lines. And then you also force line to import the model. Splitting and cleaning of data, selection of features was done before. To apply a new model, you just need to add 3-4 lines of code. And these lines of confusion matrix accuracy is exactly the same as it was before. I just added log_reg, so I know the difference. and we need to print the results. So let's run it. This is the results, and I will actually look just at the accuracy. I will not look into all the details, and you can see that accuracy is still pretty good. It's still over 80%, but it is lower than it was with our random forest. One thing that I can see here, look at the precision and recall. It's only 29%, while here we had 47.58. So you can see that logistic regression with this specific dataset works worse. Next one, let's apply support vector machines. From sklearn.svm, which is support vector machines, we import svc, and now we build and train the model. So svm_model equals svc brackets kernel linear comma random state equals 42, and then we fit in data into the model. So svm_model.feed brackets x train y train, and for making predictions we say y_pred_svm. As you can see, I keep just adding the name of the model I applied so I can differentiate them, equals svm_model.predict, and again, as always, we say x test. We feed in our test data to make predictions, and to evaluate the model, the same confusion matrix, classification, accuracy, and we printing it. This is a warning. So what we have 80% accuracy, even lower than we had with logistic regression, and here we just have zeros. Let's do the same with KNN model. Today you will learn all the models very quick. Of course, I can go into more details of each model with some different project, but here we're going very quickly through all potential models for our churn prediction. Okay, let's add KNN. So from sklearn.neighbors, we import kneighbors classifier, and again, then we need to build it, train the model. So KNN_model equals kneighbors classifier brackets, we select the number of neighbors. I selected 5, then we fit in the data into the model, knn_model.fit brackets x train y train, to make predictions. As before, we do knn_model.predict feeding x test, and we evaluating the results of the model. You can see that all machine learning models actually take 4 lines, one for importing the model, one for creating the model, for fitting data, and then making predictions. Very simple. Don't tell anyone. Okay, we have 83% accuracy. It's definitely better than support vector machine. So we have 83%. Here we have precision recall. I think it's even better than logistic regression. Is it? Yes, it is better. And the last model I will apply is gradient boosting classifier, and let's see what we have. From sklearn ensemble, we import a gradient boosting classifier, then we build in and train in our model, gbm_model equals, and then classifier number of trees we're creating, and random state. Then we fit in the data, making predictions and evaluating the results with accuracy, precision, etc. And the result is almost 87%. It is very similar to our random forest. You can see here the accuracy is the same. Here we had precision 76, recall 47, F1 score 58. And what do we have here? I think precision recall is better. You can see it's very slight difference, but very close. I was asked on social media, how do you know what model to select? You don't know. You always start with the question in mind what you are trying to achieve. So we want to predict if customer will churn or not churn. There are types of models that can be applied to solve this issue. Then you apply in all these models. Sometimes I apply 2-3 models. I don't go into all 6-7 like that. I always start with logistic regression because quite often it is the fastest, the easiest, and it can perform very good. So I usually start with logistic regression, and then I try either RandomForest or GBM, and I see the results. If you're working in a team, you present it to your team, you say what accuracy you achieved, what you tried. If you're doing it for your client, then it's up to you to decide what you believe will work best for them based on the result they're trying to achieve. That's exactly the process. You apply several models. As you saw, the whole cleaning and data preparation process happens at first. Then you just keep applying different algorithms and checking accuracy, precision, etc. If for customer 86% is enough, you stop here. If it's not enough, or maybe you didn't achieve 86, you achieved 56. Then you keep tweaking, you do feature engineering, hyperparameter tuning, you're trying to do something with data, maybe you don't have enough data, so you apply different techniques like SMOD to generate artificial data, trying to improve it. Sometimes nothing helps and you just give up and cry. As I promised, we will also do feature engineering and look at that. So feature engineering can significantly improve the performance of your ML model. For that, we're creating new features that provide more information to the model. For example, we have a column balance, and we will create a new column which will say 0 balance or more than 0. Another thing that's commonly used in feature engineering is when you create age groups, age buckets. So we will, for example, combine people who are 25 to 35, 18 to 25, etc. I also bucketed customers based on the states they live in, or if you have different countries, you look at maybe English-speaking countries together and the rest of the world. So that's what happens in a feature engineering when you create new features. It can be, for example, balance to sales ratio in our case, if person used products, is active member or not. So what we will do, I will read our file again, so we start almost from scratch. I will create a new feature to see if our balance is 0 or not 0. We're creating a new column, def square brackets balance 0 equals def square brackets balance or name of the column equals 0.sType integer. Then I will bucket our ages or create bins of age groups. So new column def age group equals pd.cut brackets, then again name of our column, comma bins equals, and then I'm saying which bins I use for grouping my data, comma labels, and this is the labels we will give. Then we're creating a new value balance to salary ratio. It will be bank account balance divided by estimated salary. We create a new column interaction feature between number of products and is active member, so I will call it product usage, where we multiply number of products and see if member is active or not. And I also create bins for tenure, for how long the customer is with us. def square brackets tenure group, name of the new column equals pd.cut brackets name of the column, bins again 0 to 5, 7 and 10, and that's the label. So it will be from 0 to 2, from 3 to 5, 6 to 7, 8 to 10. Let's run it. No errors. We need to again encode our labels how we've done it before. So label encoder equals label encoder, def gender label encoder dot fit transform, because we need to transform our gender column. That's what we've done before, and then we use one-hot encoding for our geography column. Then we create two new columns, male Germany and male Spain. We multiply gender by geography Germany. If we have a gender equals 1, male, and geography Spain 1, this product will be 1, indicating that it is male from Spain. And of course, if gender or geography Spain is 0, the product will be 0, indicating that individual is not male from Spain. So we will create these two new columns, male Germany, male Spain. It might look confusing. We also do one-hot encoding for columns age group and tenure group. Similar with get dummies, we say name of our data frame and which columns we use, and we drop the first occurrence. This time we have much more features to select. So we selected the features we had before, but we also added other columns, other features we created, and then we say that x equals our df features and y equals exited. We again split our data in training and testing dataset as we've done before, even keeping the same random state in the same test size split. Again, use scalar to scale the data and applying it to our x-train dataset and x-test dataset. Then we creating the model with RandomForest classifier, again keeping 100 trees and random state 42, model fit with X train, Y train, and then we make predictions on our test dataset. As last time, we create confusion matrix, accuracy, and classification report, and now we need to print the results and see what we've got. I don't know if it's the smartest way, but I copied the results from the previous calculation just so I can compare apple to apple. Okay, so what the result, before we'd done our feature engineering, our results were slightly better. Our precision was slightly better. Our accuracy was slightly better. This is the case with this dataset. Usually with feature engineering, you also do step by step. So in this case, I try to think of any possible option, like creating this balance zero, age groups, some ratio. Usually you do one step at a time and you see if it works. Sometimes you can, for example, change age groups. I created it in a 10-year bucket. Sometimes you create it in 5-year bucket. You can see that there is no significant improvement after we've done feature engineering, but what's good, we can see that a model performs consistently. So we again achieved almost the same accuracy rate, and other precision recall F1 score also remained the same. That was a very long video with so many models and so many things, probably a bit rushed, but we will talk about it over and over again in other videos when we create ML models. This is a foundation. That's what you do every single time. You always prepare your data for the model, then you create a model, you fit your data and make predictions, check the accuracy, and repeat again and again till you get the result you hope for. Well, that was fun. I hope you enjoyed it. I enjoyed, but it was overwhelming even for me. Let me know how it went. What model you want me to create next. Maybe we pick one of those and work with a different data set. Thank you for all your support. If you enjoyed this video, please click like and subscribe. It means a lot to me, and I hope to see you next time.